To add and subtract radicals, you need to have like radicands. I have two examples to start with. With this example, all of these radical expressions have square root 5. So what we'll do is we'll combine the numbers that are outside. Six from this one plus 1 from this middle term, minus 10. And then these all are multiplied by square root 5. 6 plus 1 is 7. 7 minus 10 is negative 3. So when I simplify this, I get negative 3 square root 5. You can only combine these by adding and subtracting when the radicands match. So with that rule, I can combine these two that have square root 3, and I can combine these two that have square root 7. I'll go ahead and group them. First, the square root 3. I have 2 minus 1 square root 3. And to that, I'll add 4 plus 10 square root 7. And I simplify. 2 minus 1 is 1. So this first term will be just square root 3. And I'll add 4 plus 10 is 14 square root 7. When you have expressions that do not have like radicands, you will need to reduce the radicals so that you do have like radicands, and then we'll do it the same way we did the ones just above. I can reduce 12. It's a square root, so my index is 2. So I need a perfect square, or I need 2 matching factors to be able to simplify this radical. All of these are square roots, so I'll need 2 pairs for all of them. 12 is 4 times 3. 4 is 2 squared. It's 2 times 2. So I have a 2 I can remove from this group. That'll leave square root 3. Like this. This next radical expression, I can't simplify this anymore. It will stay 3 square root 3. And the last one, 20 is 4 times 5. 4 is 2 times 2. So I can take a 2 out of that radical. So this last expression here is 3 times 2, and that one will be square root 5. I can combine these two expressions that have square root 3. 3 times 2 is 6, and I'll add 3 and write the square root 3 outside. The second, or this final expression, will be 6 square root 5. 6 plus 3 is 9, so I can write this first term as 9 square root 3, and then I'll add 6 square root 5. This is simplified. I have another example here. Now I need cube roots. So I'll have to have 3 matching terms to be able to combine, or sorry, to be able to simplify the radical. 32 is 8 times 4. 8 is a perfect cube, it's 2 times 2 times 2. So I can pull 1, 2 outside of this radical, and that will leave 2 cube root 4. For the second group, I need to break down 108. Let me get my calculator. I was just confirming. I didn't want to tell you wrong. Lose my mind. 4 times 27 is 108. 27 is a perfect cube. It's 3 cubed. So I can pull a 3 out of this radical. And then my second expression will be minus 4 times 3 cube root 4. And then I have plus 2 cube root 4. I can't simplify cube root 4 because 4 is 2 times 2, and I would need 3 matching factors to be able to simplify. Now I can add these, now that they all have square root 4. I'll add 2 minus 4 times 3 is 12, plus 2, and each of these has square root 4, so I put the square root 4 at the end. 2 minus 12 is negative 10, plus 2 is negative 8. Negative 8 square root 4. That's simplified. You have another one. 45. These are all square roots, so now my index is 2. Square root 45. 45 is 9 times 5. 9 is 3 times 3. So I can write square root 45 as 3 square root 5. And then I'm adding 2 times square root 20. 20 is 4 times 5. 4 is 2 squared. So I can simplify a 2 from that group. I'll have 2 times 2 square root 5. This 5 stays in, just like this 5 stayed in. And 24, I can simplify. This is 4 times 6. 4 is 2 times 2. 6 is 2 times 3. So I'll have to leave the 2 times 3 inside. This is not helpful. I'll just leave the 6 in and pull the 2 out. So this is minus 2 times 2 square root 6. And I can combine the first two terms. They both have a square root. They each have a square root 5. So this is 3 times 4. Sorry, 3 plus 4. Square root 5 minus 2 times 2, 4, square root 6. When I simplify this first term, I have 7 square root 5 minus 4 square root 6. I have one more example. Here we're taking fifth roots, so I'll have to have 5 matching factors. Then I have a square root 8 to simplify. This one has a factor of, or a index of 2. Obviously, when I have fifth root of 2, I can't simplify that. 2 is 2 times 1, so this will stay 3 fifth root 2. There's nothing more I can do with that. And then 64, I can break down. This is 8 times 8. 8 is 2 cubed. I'm looking for 5 matching factors. So if I break these down to prime factorization, I have one set of 5 2's. So I'm going to move this down a little bit. Sorry. There, that's better. I I have 2 already outside, and I'll bring a 2 from inside the radical, and that leaves fifth root 2. And then I will add square root 8, which can be simplified. 4 times 2, 4 is 2 squared. So here I'm looking for a pair of factors that match. So I can write this as 4 square root 2. I can combine these with fifth root 2. And I'll have 3 plus 4, fifth root 2, which is 7, fifth root 2. And then to that I'll add 2 square root 2. Since the radicals don't match, I can't combine those. Okay. So, big idea here. When can you add and subtract radicals? As we said, if the radicands match. Not sure why I'm wobbly there. That's better. And what do you add and subtract? Well, we only changed the numbers outside. We combined. How about that? The numbers outside. All right, that's it. Purpling. Goodness, come on.